Hi Algebra 2, this is Unit 6, Lesson 6, and today we're going to talk about the zero product law. So if I have the product of multiple factors is equal to 0, then at least one of the factors must be equal to 0. So say I have A times B equals 0, then either A has to equal 0 or B has to equal 0. Right? So if you have two things that are multiplied and together they equal 0, one of those things has to be equal to 0. Otherwise, when you multiply them, they wouldn't be equal to 0. All right, so let's look at this, how it's actually used. So in this first exercise, I want to solve each of the following equations for all values of x. So x plus 7 times x minus 3 equals 0. Well, if they equal 0, one of them has to be equal to 0. So basically, I'm going to take both of them, set them both equal to 0, and solve. All right, so you sort of divide this up into two problems. X plus 7 equals 0 and x minus 3 equals 0. And the only thing that happens, and I solve now for x, is that I do the opposite. And I subtract 7 from both sides, so x winds up equaling negative 7. And on the other one, I'm going to add 3 to get x by itself. And I have x equals 3. So you get two answers, and those two answers can be written like this. I have negative 7 and 3, two separate answers. All right, so that's all we're doing. I know you did this back in algebra also. So B, 2x minus 5 and x minus 4 equals 0. So I just take each one, set each one equal to 0, and solve. So the one on the right is a little bit easier. X equals positive 4. Right, I'm sort of skipping that middle step right now. 2x equals 5. I bring that negative 5 over to the other side, and now I divide by 2. X equals 5 halves. You can leave it just like that. All right. You want to write it as 2.5. That would be perfectly fine. And there are my two answers. Now, what happens if I have a term in front? Okay, I got to set each thing equal to 0. 4 equals to 0, 3x plus 2 equals to 0, and 4x minus 3 equals 0. All right, so 4 basically doesn't equal 0, but let's do the other ones. So I'm going to subtract 2. So that's going to be 3x equals negative 2, and divide by 3, x equals negative 2/3. And then I'm going to add 3 on this last one. Bring the 3 over to the other side, so x equals 3/4. Okay, so 4 doesn't equal 0, so I'm basically just going to disregard that, and my answers are negative 2/3 and 3/4. All right, let's talk about that 4 equals 0 though. All right, in exercise 1C, why does the factor of 4 have no effect on the solution set? So the zero product law, okay, says that at least one of the factors has to equal 0. So zero product law, at least one factor equals 0, okay? That doesn't mean all of the factors have to be equal to 0. So basically, if a factor is a constant, then it has no effect on the solution set. Then it has no effect on the solution set. Okay, not all the factors have to equal 0, just one of them does. All right, so this is what we're going to be using to solve a quadratic equation. You're going to get the equation in standard form. That means it's going to have everything on one side, and you're going to have equals 0 on the other side. So first you want it, step 1, get it in standard form. Factor if possible. Then I'm going to set each factor equal to 0, and then I'm going to solve each of those equations. Okay, so let's look at it and see what it's going to look like. So exercise 3, I'm going to solve using that zero product law. So I want to get it in standard form, which means everything needs to be on one side. So I'm going to take this negative 2x, and I'm going to bring it to the other side by adding 2x. So it's going to be x squared plus 5x. I'm going to take this positive 10 and I'm going to bring it to the other side by subtracting 10. Negative 14 and negative 10 is negative 24. So that's step 1. Put it in standard form. Everything's on one side. You have equals 0 on the other side. Step 2, factor. All right, so this is just a trinomial. There's no greatest common factor to pull out. X times x is x squared. I'm looking for numbers that multiply to 24 and combine together to give me a 5. Well, 8 times 3 is 24. And the only way 8 and 3 are going to give me a positive 5 if it's a positive 8 and a negative 3. And then all I do is I set each of the factors equal to 0 and solve, which means my answers are negative 8 and positive 3. Got negative 8 and positive 3. Okay, and that's it. All right, B, bring everything to one side. So I'm going to subtract this x squared and bring it over to the left. 3x squared minus x squared is 2x squared. I'm going to subtract the 3x, bring it over to the left, and that gives me 9x. And then I'm going to add 2. So everything goes to one side. I'm putting it in standard form. Now this time I have a coefficient in front of that x squared, which makes it just a little bit more tricky to factor. Though this one's not bad because there's only one combination that I have to try. 2x times x is 2x squared. And I want the factors of 5. Again, there's only one choice, 1 and 5. So it's just a matter of where I put the 1 and the 5. Be careful because whatever number you put here is actually multiplied by 2. So if I put the 5, and I want to get a positive 9. So if I put the 5 here, that's 10. And I put the 1 here, that's 1x. And how are 10x and 1x going to give me a positive 9? If it's a positive 10x and a negative 1x. All right, then I just take each of these and set them equal to 0 and solve. So I bring the 1 over to that side and x is 1/2. And I bring the negative 5 over, x is negative 5. So my answers are 1/2 and negative 5. All right. Number 4, consider the system of equations. So I got 2 equations, all right? And I want to solve them, find the intersection of these points algebraically. So I'm going to basically use substitution. And you did this back in algebra also. Substitution. They're both equal to y. All right, so basically since they're both equal to y, I'm going to take this right here. Since it equals y, I'm going to substitute it in for y right there. So 3x squared minus 8x plus 5 is equal to 4x plus 5. Y was equal to 4x plus 5, and I substituted in for y 3x squared minus 8x plus 5. Now I want everything on one side, just like I was doing up above, so I'm going to subtract 4x. That's going to give me a negative 12x, and I'm going to subtract 5. Which cancels out. All right, well that was convenient. Now the first step in factoring is always to look to see if there's a greatest common factor, and there is a greatest common factor. If I pull out a 3x, both of those terms are divisible by 3x. Divide out a 3x, I'm left with x minus 4. Same thing, just set each factor equal to 0. So x equals 0. And x equals 4. And then you actually have to solve for y. So if I plug in 0, it's probably easier just to do it into the first one right here. So if you plug in 0 right there, so that's going to give me 4 times 0 plus 5, so y equals 5. And if I substitute in 4, y equals 4 times 4 plus 5, that is 21. So I have 2 sets of answers. I got 0, 5, x is 0, y is 5, And when x is 4, y is 21. Okay, and using your calculator, sketch a graph of this system to the right. Be sure to label the curves with equations and the intersection points and the window that I used. All right, so I know that one equation is 0, 5. One solution is 0, 5, and the other one is 421. So you got to be a little bit careful right here. But if you plug these both into your calculator, so do that now. You can pause the video if you need to. You have x and y. And I actually have two sets of y's because I'm going to plug both equations in. Although you don't have to do the line. The line was y equals 4x plus 5. It's probably just easier to graph it by saying the m and the b. M is your slope is 4, B is your y-intercept, which is 5. And this is just a sketch, okay? So it's nothing that has to be perfect right here. But if you look at it on your graphing calculator, it goes, maybe I'm going to do the parabola first. So I'm going to copy down my table. So I just did -1, 0, 1, 2, 3, just to get a sketch right here. And his answers were 16, 5, 0, 1, and 8. And this was 1, 5, 9, 13, and 17. Okay, so just to get a little idea here, I'm just going to go by 5s, and I'm going to go by 5 over here. All right, so this one, it was 421. So actually, this is going to be a little skinny right here because I had 4 and 21 was the solution. So this line, just go like here. Okay, goes something like this. And then my parabola, I'll leave that like that, has to go something like this. It has to go through that point right there. And then it's going to go below and back up. Again, it was just a sketch. All right, and then you can verify your answers. If both of those equations are in your calculator, you can hit that intersect command on your calculator and you can see what your solutions are. All right, and if we flip over to the last page, the zero product law is important in finding the zeros or the x-intercepts of a parabola. So basically it's your solution right here. So here we have our parabola. It's already graphed for us just to look at a problem that's a little bit different. I want to write down the coordinates of the two x-intercepts of the graph. All right, the two x-intercepts. So basically I'm looking where I'm highlighting right here. My two x-intercepts, x is equal to -1 and x is equal to 3. Okay, those are my x-intercepts. And now let's find the x-intercepts of this parabola algebraically. So my x-intercepts are when y equals 0. Okay, my x-intercepts are when y is equal to 0. So I'm going to take those two solutions that I had back there. All right, and I am going to, so I'm basically going to, x is 3 and x is -1. I'm going to work backwards. So basically that means x minus 3 is equal to 0 and x plus 1 was equal to 0. So those are my factors. Okay, and if I was to multiply those, I would get my x squared, let me get a pen, x squared minus 2x minus 3. All right, so again, let's start from what I had. I had y equals x squared. I just want to show you how they're related right here. The x-intercept is where y equals 0. So I did this. I should have done this one first and then worked backwards, sorry. And then I factor it. So my factors are x minus 3 and x plus 1. And I set each one equal to 0. So I get x equals 3, x equals -1, which is the same thing I had back here. Okay, but I just want to show you how I could take these and set them equal to 0 and work backwards and multiply them, and I get that same answer that I started with over there. All right, so how do I algebraically find the set of x-intercepts or zeros for each parabola? Is you are going to plug in 0. Okay, the x-intercept is when y equals 0. So I'm going to plug in 0 for y, and I'm going to do what I've been doing all along, is that I am going to factor. This is the difference of two perfect squares. So it's 2x minus 1 and 2x plus 1. That was an easy one. And then I just set each factor equal to 0 and solve. Right, so I don't need to do it graphically. I can just do it algebraically. And those are my two solutions. All right, same thing here. I'm going to plug in 0 for x. This one's a little bit harder because I have a number in front of the 3. But there's only one choice. The only way to get 3x squared is to multiply 3x times x. And I'm just going to have to play around with the factors because they could be 1 and 10 or 2 and 5. Now, if they're 1 and 10, if the 10 was here, that would be 30. That's like way off, so it's not going to be 1 and 10. So let's try the 2 and the 5. So if I have 2 and 5, 5 times 3 is 15, 2 times x is 2. Yep, that'll give me a positive 13 if it's a positive 15x and a negative 2x. And then I set each factor equal to 0 and I solve. So I'm just basically adding on one extra step from the factoring that I was doing. You set each factor equal to 0 and then you solve them. Okay, and this one right here has a greatest common factor. The last one, number C, has a greatest common factor I can pull out. I can pull out a 5x, and I'm left with x minus 2. And each factor is set equal to 0. So basically when I divide by 5, x equals 0, and I add 2, x equals 2. And those are my two answers. All right, and so we will practice that tomorrow.